This is a little tour of the configuration control and quality control systems that we've implemented for our SuperAWOSs around the country. There's a secure portal access that's given into a server at our location, at our central location. On that server there are these various databases with hyperlinks to pieces of data within those databases. Let's look at Potomac Airfield as an example. First hyperlink is simply a quick reference over to the AirNav page. AirNav is a publicly available site that has all types of information that's fed by the FAA 5010s. Next hyperlink over is an internal page we use for configuring the software of equipment in the field. And then when the equipment in the field actually wakes up, it sends us this data. So these records are actually synchronized with what's going on in the field as the equipment reports to us. Next hyperlink over is a page that accesses all of the initial QC and certificates. For example, let's look at the serial number, and there's the visibility sensor. And this is actually the NIST certificate for the visibility sensor that's at Potomac Airfield. For example, we actually do performance QC on each individual antenna, which is critical for Unicom operations. We use QC for radio performance and transmitter and receiver things that are all critical for operating adaptively and non-interferingly on an airport's Unicom. Here, for example, is the NIST certificate on the temperature sensor. Same kind of thing. It's all traceable. Next hyperlink over is a brief page. This brief page, which will take a second to download, actually, here we go, let's move this down here. This hyperlink will actually open all of the last 90 days weather coming from Potomac Airfield. It's all uploaded to our server by SATCOM and by Netlink. So this is, at any point, you can download 90 days of weather data. If you want to, you can download all of the weather data from the day the equipment first turned on. That's all downloadable. And another fascinating report, this is actually the communications that occurred on the frequency by hour of every single day. So for example, this tells me on this date, this time, local, that there were 3 air-to-air conversations. There were no greetings, there were no radio checks, but there were 2 advisories given out to pilots. You contrast this, for example, an hour before. There were 16 conversations on the frequency. There were no greetings given to inbound pilots by the equipment, but there were 4 radio checks and 3 weather advisories. Next hyperlink over is, takes a second. This is the FAA 6030 form. Here you can see a startup report. Equipment starts up. This tells us that the transmitter is actually on the right frequency. This is actually telling us not that we hope it's on that frequency, but that it is on that frequency. VSWR is telling us that the antenna is tuned correctly. The RF power actually tells us that there is energy going out the antenna. So the first one's frequency, VSWR is antenna loading, third is power going out. Percent modulation tells us that there's actually voice going out over that transmitter. That is not just carrying carrier, but there's actually voice going out over that. In this case, this actually tells us the RFI noise floor of the equipment, which is critical if you're operating dynamically on a shared frequency. The first key is to be able to detect when others are transmitting, and to do that you need to be able to detect their transmissions. So that's a key parameter. These are the various diagnostics on what we call the advisory sensors. It's all very straightforward. And this last page here shows you, for example, that the current altimeter when this test was done was 30.00. That the altimeter sensor number 1 has a 0.001 correction. Altimeter number 2 has a 0.014 correction. What that translates to is a 2-foot difference between sensors well within spec, and that's perfectly okay. So that tells us the altimeter sensors are both working, they're both within spec, and everything's fine. On the visibility sensor, this tells us that the window sensors are clean. This tells us that the day-night sensor is detecting a value. It's currently day. Everything's working fine. Infrared level and infrared receiver gain are 2 parameters used for telling us how hard the visibility sensor is working to maintain its calibration. These reports tell us everything we or anyone could want to know about any given piece of equipment in the field. Next hyperlink over is the daily report. Let me open that one up. This is monitored every single day. And we actually have software watching the software because that's the only way to capture this much information. This tells me on this date that the voice modulation from that transmitter was 94%, the noise floor was minus 113, the VSWR is 1.4 to 1. For example, if an antenna is coming loose, or we actually detected a mouse chewing on a cable, because we saw the VSWR starting to climb from day to day. This tells us the RF power figure. This is the infrared and receiver gains for the visibility sensor and the window contamination. So this tells us that the visibility sensor is perfectly all right. Everything's well. Next one over is a feed from NOAA, which actually has responsibility and authority for the quality control of weather information in the United States. Here's a little map that shows Potomac Airfield. Here's a map that shows the sensor data that NOAA is getting that are being compared to validate Potomac Airfield. This tells us, Mattis is telling us that we have 2 thumbs up. Here's a graph. The red line is the altimeter value given by all the other sensors in the area. The blue is the altimeter value coming from Potomac Airfield. Obviously, they're tracking very, very closely. Note the scales. This is very, very close, which means that the altimeter at Potomac Airfield is being compared to multiple sensors in the area, and everything's correlating. So not only is the integrity check internal, but it's also compared to independent sensors. Same thing with temperature. Here you see Potomac is in a valley, so it gets a little cooler at night than the surrounding sensors, but that all makes sense. So you can see how that works. Same thing with dew point. Going down here, this is a list of all the other sensors that NOAA is using for the statistical analysis that are located in their database. This shows us, for example, Andrews Air Force Base 6.4 miles to the northeast. And these are all sensors. Some of them are scientific, some of them are National Weather Service, some of them are academic, some of them are research, but all of these feeds into the system are providing QC for the sensors at Potomac Airfield. NOAA, as well as our own server, sends us email messages should any data be outlying statistical correlation. And that's the tour. Thank you.